Good evening. Yesterday we started with geometric progression. What is geometric progression? If the ratio of two consecutive terms of a sequence is constant, then that sequence is called a geometric sequence or geometric progression. The first term of the geometric progression is usually taken as A and common ratio as R. Then general geometric progression is AR square, AR cube, etc. What is formula for nth term of GP? It is A into R raised to n minus 1. And what is Sn? Sn is nothing but, I'll mention the formula. Tn is A into R raised to n minus 1. And what is Sn? A into 1 minus R raised to n upon 1 minus R. We use this if R is less than 1. And if R is greater than 1, actually formula is the same. If R is 1, we cannot apply this formula. Terms are in GP, even if R is 1, then the terms are A. Each term is A. So if you add A n times, you get n into A. So this formula for R equal to 1. Now with sum number 8, we have to solve. Find 5 numbers in GP such that their product is 1024 and fifth term is square of the third term. Right on. Let 5 numbers in GP be A upon R square, A upon R, AR square, right down. Product is A upon R square into A upon R into A into AR into AR square is given to be 1024. Now this is A raised to 5. A raised to 5. What is 1024? You will notice that it is 2 raised to 10. That is 4 raised to 5. Don't say plus minus. A has to be plus 4. So A equal to 4. Right? Now, which is the next condition? Fifth term is square of the third term. That is AR square is square of A. That is A square. So that gives me R square equal to A. But A is 4. So R is plus minus 2. Now take A equal to 4 and R equal to 2. So the numbers are 1, 2, 4, 8, 16. Take A equal to 4 and R equal to minus 2. So what are the numbers? See, some students may say these values give 16, 8, 4, 2, 1. No. With these values, we get 1, minus 2, 4, minus 8 and 16. Sum number 9. The 8th term of a GP is X. 8th term of a GP, or rather the 5th term of a GP is X. 8th term is Y and 11th term is Z. Verify whether Y square equal to XZ. Now T5 is X, T8 is Y, T11 is Z with usual notation. What is nth term? It is AR raised to n minus 1. Now fifth term is nothing but AR raised to 4. So AR raised to 4 is X, AR raised to 7 is Y, AR raised to 10 is Z. Now Y square equal to A square R raised to 14, XZ equal to this into this. So clearly they are equal. Note that when I say y square equal to xz, means x, y, z are in geometric progression. Now my question is, can we draw any conclusion from this? Conclusion is, for a GP TA, TA plus D, TA plus 2D are also in GP. Observe the term numbers 1, 2, 3 or 1, 3, 5 or 1, 7, 13. These terms are GP. Rather, these terms of GP will again be in GP. Now sum number 10. If PQRS are in GP, show that P plus Q, Q plus R plus S are also in GP. Right on? Let R be the common ratio. Now use capital R because small r is already taken. I'm dictating solution for sum number 10. Right done? Let capital R be the common ratio of GP. Common ratio of GP. Then Q equal to, see on the screen, Q equal to P capital R. Q key, R is the second term which is obtained by multiplying first term by common ratio. Okay. What is small r then? It is QRR. Rather PRR, not Q. So this is nothing but PR square. And what is smallest? It is nothing but PR cube. I hope you are getting this. To get the next term of GP, multiply by common ratio. We have to prove or verify. Prove. We have to prove. Right on? That P plus Q, Q plus R plus S are in GP. That is to prove Q plus R upon P plus Q is R plus S upon Q plus R. I hope you are getting this. To prove that three terms are in GP is to prove that second upon first equal to third upon second. Now LHS, Q plus R upon P plus Q. Substitute the values. What is Q? PR. What is small r? PR square divided by P plus PR. Now tell me what can be taken common from numerator? PR. So in bracket 1 plus R. Here P 1 plus R. So this is nothing but capital R. That's it. What is RHS? R plus S upon Q plus R. Now replace R by what? PR square plus PR cube upon Q plus R. What is Q? PR. And what is R? PR square. Now from numerator, PR square can be taken common to get 1 plus R. This should be capital R, not small r. I'm sorry. Now from denominator, you have to take PR common to get again 1 plus R. So what remains is again capital R equal to LHS. That's it. Sum number 11. The number of bacteria in a culture doubles every hour. If there were 50 bacteria originally in a culture, how many bacteria will be there at the end of 5th hour? Write the solution. From the given information, the number of bacteria every hour, form a GP, with small a equal to 50, and R, small r, equal to 2. R equal to 2. To find the number of bacteria at the end of 5th hour, we have to find T6. Now T6 equal to, yes, what is the formula? AR raised to n minus 1. So AR raised to 5. Now substitute the values. So 50 into 2 raised to 5. 2 raised to 5 is 32. So 50 into 32. 32 half hundreds means 1600.
Twelfth sum. A ball is dropped from a height of 80 feet. The ball is such that it rebounds 3/4 of the height it has fallen. How high does the ball rebound on 6th bounce? How high does the ball rebound on the nth bounce?
Write down the solution. The height in successive bounds. Let me complete the solution first. If you have difficulty, you can definitely ask me. The height in successive bounds form a GP. The heights in successive bounds form a GP with R, small r, with R equal to 3/4. With R equal to 3/4. Since the ball is dropped from a height of 80 feet, height at the first bounce equal to small a equal to 80 into 3/4 equal to 60. Therefore, height in the 6th bounce equal to a into r raised to n minus 1 is the formula, but here n equal to 6. So ar raised to 5. Substitute the values. You need not simplify this. Just keep this as 60 into what is R? 3 upon 4. Yes, this is the answer. Of course, unit will be feet. Now, what is asked? Height in the nth bounds. AR raised to n minus 1. (60) into 3 upon 4 raised to n minus 1 feet. Right.
The numbers 3, x and x plus 6 form R in GP. Find x, 20th term and nth term.
Okay. Write down. 3x, x plus 6 are in GP. So second term upon first term is third term upon second term. So x square equal to what? I'm cross multiplying. 3x plus 18 x square minus 3x minus 18 equal to 0. Now, can we find the factors of this? Yes, we can. You should be able to find factors immediately. X minus 6, x plus 3. So x equal to 6, x equal to minus 3. Okay. Now what is asked? 20th term. Oh, so for x equal to 6, we'll have to find 20th term. For x equal to minus 3 also, we'll have to find that term. Okay, we'll do that. And what is asked? Nth term. Okay. So for x equal to 6, what is common ratio? 6 upon 3 equal to 2. Therefore, T20 AR raised to 19. A means first term. So 3 into 2 raised to 19. Now for this, I will find Tn. Tn is AR raised to n minus 1. So 3 into 2 raised to n minus 1. I hope this is clear to you. Okay. This is for x equal to 6. Now you will find for another value of x minus 3. First, we will have to find common ratio. For x equal to minus 3, what is common ratio? How to get common ratio? Divide second term by first term. So common ratio is minus 1. So what is T20? AR raised to 19. A means first term. It is 3 only. Minus 1 raised to 19 is what? If index of minus 1 is odd, result is odd. So it is minus 3. What is Tn? AR raised to n minus 1. 3 minus 1 raised to n minus 1. Keep this as it is. That's it. Sum number 14. Mosquitoes are growing at rate of 10% a year. If there were 200 in the beginning, write down the number after 3 years, 10 years and n years. Write the solution. See, initial part we have to write, rather you have to write if you want marks. Since mosquitoes are growing at 10%, since mosquitoes are growing at 10%, and there are 200 in the beginning, and there are 200 in the beginning, the number of mosquitoes in successive years, form a GP with small a equal to 200 and r equal to, you have to be careful. Tell me what is small r? R will be 1 plus 10%. Percent means per 100, for every 100. So 10 upon 100. That is 11 by 10. 11 by 10 times the original number. Therefore, write down number after 3 years number after 3 years is T3. I'm sorry, after 3 years. After first year, in the beginning, first term T1, which is small a. After 1 year, T2. After 2 years, T3. After 3 years, T4. And what is formula for T4? AR raised to 4 minus 1, that is AR cube. Now A is 200. So 11 upon 10 cube. You need not simplify this. Just say 200 into 1.1 cube. Now use common sense. Number after 10 years it will be T11. I'll write directly 200 1.1 raised to 10 and number after n years. It is simply Tn. Not simply Tn. After n years, we have to be careful. After n years. So Tn plus 1, which is AR raised to n. So it is 200 into 1.1 raised to n. Right now.
Sum 15. The numbers x minus 6, 2x and x square are in GP. Find 1x, second, first term and third, nth term.
Good. Now, what is given? Start writing solution. X minus 6, 2x, x square are in GP. Therefore, 2x upon x minus 6 equal to what? X square upon 2x. That is, cross multiply, 4x square equal to x square into x minus 6. Now, can we divide both sides by x square? Yes, we can. How can x square be 0? No. Therefore, 4 equal to x minus 6 as x square not equal to 0. So what is x from this? 10. Now what is asked? First term. First term is nothing but x minus 6. That is 10 minus 6 equal to 4. And nth term is asked. Okay. Nth term is ar raised to n minus 1. Now what is first term? 4. Can you tell me the common ratio? Okay. We should have found that first. No problem. It is x square upon 2x, right? X square upon 2x, that is x by 2. But x is what? X is 10. So 10 upon 2, that is 5. So it is 4 into what? 5 raised to n minus 1. Right. Exercise 2.2 now. Actually, this is based on formula for some of the first n terms of GP, which we have already proved. So first question, for the following geometric progressions, find Sn. Now we are given that sequence is GP, so we need not verify that. First one, 3, 6, 12, 24. So for this GP, what is small a? 3. What is common ratio R? Second term upon first term, 2. So what is Sn? Common ratio is greater than 1. So a into r raised to n minus 1 upon r minus 1. Substitute the values. You get this. Now can you tell me second GP? Yes, please read. Second geometric progression. Anybody? Okay, check this. Is this PQ Q square upon P Q cube upon P square? Is it? Just check this.
It's only q cube upon p, not p square.
Again P. No, no. Then terms will not be in GP. This is GP. P, Q, make the correction because common ratio is Q by P. This is correct. So first term is small p. And what is common ratio? Second term upon first term. You may say, no, I want to obtain common ratio by dividing fourth term by third term. Same thing. So Sn. Now you will ask me how to know whether it is greater than 1 or less than 1. Formula is the same. So you may take greater than 1. So r raised to n minus 1 upon r minus 1. So it is P Q upon P raised to n minus 1 upon Q upon P minus 1. Just check this. Simplify. So Sn comes out to be, I'm writing this directly, p square upon q minus p into q upon p raised to n minus 1. Write down. Third part, for GP 0.7, 0.07, 0.007, what is A? First term 0.7. What is common ratio? Second term upon first term, that is 0.1, less than 1. So we have to go for this formula. Substitute the values and simplify. You should get 7 upon 9 into what? Into 1 minus 0.1 raised to n. Write down. Now last one, for GP, I will directly write A equal to root 5. I'm talking about the fourth part. And how to get the common ratio? Second term minus 5 upon root 5. See, 5 itself is what? Root. So one root gets cancelled. So what is the common ratio? Minus root 5. See, these are the basic things. So Sn upon 1 minus r, I will directly write 1 plus root 5. Basically, it is 1 minus root 5. Second question, for a GP, first one, A equal to 2, R equal to minus 2 by 3. Find S6. Now, common ratio is less than 1. So, Sn is A into 1 minus R raised to n upon 1 minus R. So, what is S6? A is 2, 1 minus 2 by 3 raised to 6. Index is even. So, this is positive. So, 1 minus 64 upon 729 upon 5 by 3. Now LCM is 729 less 64. So 665 upon 729. So 2 into this. Now 1 upon 5 by 3 is 3 by 5. So on simplification, you get 266 upon 243. Second one, if S5 is 1023, R is 4, find A. Now it is S5 A into R raised to 5 minus 1 upon R minus 1, but R is given to be 4. So we get A into, what is 4 raised to 5? 4 raised to 5 is nothing but 2 raised to 10, which is 1024 less 1, that is 1023. Gets cancelled with this. So what is A? A equal to 3. Now third sum, first part is for homework, simple one. For a GP, A, small a is 2, common ratio is 3, Sn is 242, so find n. You get 3 raised to n equal to 243, which is 3 raised to 5. So 3 raised to n, 3 raised to 5, so n equal to 5. Second, for a GP, sum of the first 3 terms is 125 and sum of the next 3 terms is 27. Find the value of common ratio. Now S3 is 125. Sum of the next 3 terms means S4, S5, S6. It is 27. But T4 plus T5 plus T6 is 27. But T1 plus T2 plus T3 is 125. This means S6, T1 plus T2 up to T6 must be 125 plus 27. That is 152. Now take the ratio. What is S3? A into R cube minus 1 upon R minus 1 upon what is S6? A into R raised to 6 minus 1 upon R minus 1 equal to 125 by 152. Now simplify this. So what remains is R cube minus 1 upon R raised to 6 minus 1 What are the factors? R cube minus 1, R cube plus 1. So 125 R cube cross multiply. See what is important, solving an equation. So 125 R cube, 152 less 125, that is 27. So R cube is 27 by 125. So what is R? Take cube roots. Don't say plus minus, only plus 3 upon 5. Fourth question, for a GP, first part, third term is 20, sixth term is 160. Find S7. Take the ratio. Now T6 is AR raised to 5 upon AR square is 8. R cube is 8, so R is 2. Now third term is AR square 8, but R is 2, so that gives me A equal to 5. So S7 will be this one. Substitute the values. Tell me what is the final answer. It will be 5 into 128 minus 1, that is 5 into 127. That is 635. Check this. Second is similar. Answer is 2046. So that's it for today.